Okay, y-intercept, we're going to let x be 0. So if x is 0, y is 0. No problem there. That's an easy peasy thing there. Okay, then what about the x-intercepts? And I don't think we really need the factor theorem here, or what we did with the smiley face. If we just let that equal to 0, then what I can do is I'm going to take out an x squared, and I'm left with 6 minus x. Okay, there we go. And then I could say, well, x is equal to 0, x squared is equal to 0, so x is 0, or x is equal to 6. So there's your x-intercepts. Okay, what about your turning points? Okay, and by the way, also, just let me just show you something. The shape, it's a negative x cubed graph, so it's going to do that. So we know that we've got a minimum and a maximum there. So what would be the fx? We know it to be 6x squared minus x cubed. So if we differentiate that, we're going to get 12x minus 3x squared. Okay, and then at the turning point, your derivative is 0. Okay, now let's divide throughout by 3. And of course, with this thing, let's factorize it. So our turning points would be at 0 or at 4. Okay, what is the f of 0? Let's plug in what is the original. There it is there. It's 6 times 0 squared minus 0 cubed, which is 0. So there's a turning point at 0, 0. And then what about at the f of 4? So that would be 6 times 4 squared minus 4 cubed. And if you work that out there, it comes to 32. The f of 4 would be 32. So you've got a turning point at 4 and 32. It doesn't have to be perfectly drawn to scale. Okay, now the points of inflection. Let's have a look at this. As I say, you could add up the x values of the turning points and divide by 2. Or what you could do is you could take the first derivative there, which is 12x minus 3x squared. Where did we get that from? From our first derivative there. And then you differentiate again. So you get the second derivative, which is 12 minus 6x. Put it equal to 0. And this looks very comfortable. It gives us at 2 as a point of inflection. So all we have to do is go back to the original now, plug in 2. So what's that original going to be? It's going to be 6 times 2 squared minus 2 cubed, which is 24 minus 8, which of course is 16. So the point of inflection happens at 2, 16. I like it. Okay, now let's get a set of axes quickly, and let's plot this thing. So we've got a turning point and an x-intercept at 0, 0, which is great. Then the other x-intercept was at 6, 0. Okay, there we go. It's 6 and 0. And then we've got a turning point at 4. So that's 1, 2, 3, 4, and 32. Let's put it there. And also our shape is going down like this. So what's going to happen? The graph comes down, goes up there, and it's going to change its shape, turns, and comes all the way down. There we go. And your points of inflection would be there at 2 and 16. Okay, so the x-intercepts, let's check them. 0 and 6. There we go. X-intercepts are fine. Y-intercept is at 0. Okay, your turning points would be at 0, 0 and 432. 0, 0 and 432. And your points of inflection is at 2 and 16. And there we've got our cubic graph. What a pleasure. By the way, if you want to get the x value of the points of inflection, take the x values of the turning points, which is 0 plus 4, and divide by 2. So it's 4 over 2, which in fact equals the 2 there. Or get the second derivative equal to 0, and so it works that way. Okay, stay with us, guys. We'll be back for some more cubics in the next lesson.